Hello, everybody, and welcome back to another episode of High Performance Delta. I'm joined again with Youssef, who's a Databricks savant, and I'm just super happy to have you here. And then I'm Scott Haines. You've seen me on the show before. The only thing that's changed is I'm no longer at Nike. I'm now a developer relations engineer for a company called Buff. And with that said, today Youssef and I are going to go over our favorite new features of Delta Lake 4.0. And with that, we're just going to start to kick off the slide deck and walk through things. So I hope everyone is excited and happy Tuesday. So what's new in Delta 4? There's a lot of new things in Delta 4. There's also a lot of new, new and improved things that were already in Delta 3. And so as we walk through all this, I think one of the things to kind of keep in mind is that everything keeps on getting better with every release. Performance keeps on getting better in every single release. And so things that, might feel old because you've heard the name before are getting better as well. So during today's session, we're going to also, recap a little bit of that as we go back through liquid clustering again. But Youssef, is there anything you want to say before we kick off?
No, I'm just happy to be here for the second time.
Awesome. Cool. All right. Cheers. So I guess we'll go directly into the slides now. So starting off with Delta Connect. People have talked about Delta Connect before, kind of in passing, because this has been essentially in preview for a while. Delta Connect is essentially just a plugin on top of Spark Connect. And Spark Connect came out a while back in the 3.4 release of Spark, which allowed you to have a gRPC connection from essentially a local thin client that felt like a normal kind of local driver in Spark up to a remote server, which didn't feel much different than a typical kind of, Spark master or anything else like that. So technically, in theory, a lot of what is being done feels the same. The only difference is the protocol is just all protobuf back and forth. The neat thing about this is that rather than being essentially stuck in the JVM, you can now create a Rust client. You can create a Go client. You could, whatever comes out next, you create a Zig client, doesn't really matter. As long as you have the capability of being able to handle the protocol and then decide to do things within the realm of what is available inside of Delta. If you want to hit the QR code, you can. If we're going to share this out anyway, so you can take your time as well. If you want to go and take a look into the docs as well. The QR code is essentially just a pointer to the Delta Connect docs. So the cool thing, it decouples your Spark architecture, which is nice. It makes it easier for you to actually upgrade from versions of Spark, because your thin client doesn't need to know a lot about how Spark works. It needs to know a lot about how data frames work. And so all the magic really happens once essentially an unresolved logical plan makes it up to the server. I don't have a cool pointer, so I can just move my hands back and forth. But if we take a look at the overview architecture on the side, we essentially have our Spark session, which is within our Spark client. That's our thin client. It feels like a driver program. Let's just call it it's oh yeah, that's our driver program. But actually the real driver program is still occurring up at the server. So essentially we sort of have two drivers. One's a remote controller for the server side driver. So your client will create a data frame, and I'll just pass messages back and forth up to the Spark Connect server. And then from there, if you have a normal sized Spark cluster, all the distributed computation, everything else will continue to work as expected. The only difference is now with Delta Connect and the new plugin, you have the ability to actually communicate to your Delta tables, do transactions, do merge operations. It's all neat. And so we're going to go into that in a little bit as we go through the actual demos. So essentially dropping down a little bit, we talked about kind of the bottom to top architecture. Now we're just looking at left to right. It's pretty much the same exact thing. But if you think about the thin clients, right? It can be created in a language that doesn't currently support Spark natively. The other neat thing too is that it's fairly easy to drop all of this into a Jupyter type notebook. So if you want people to be able to test things out quickly, that's awesome. Or if you wanted to create a language specification or anything else like that to creates a plugin for IntelliJ, for example. There's neat things that could happen within the ecosystem because the client itself is tiny. All it needs to know is how to create a protobuf message and then send it to an endpoint that knows how to receive that protobuf message, which is kind of neat. So with that said, we're going to move on into a little bit of kind of a preview before we get into the demo. So we talked about how we have a client. We talked about how we have a server. for us to be able to connect the two of them, we actually have to run two processes. So for the connect server, we essentially just need to be able to go and run that process. So I hope the command is showing up big enough for people to see it. If it's not, we're going to share the slides out anyways. I'm also sharing the actual source code for all of this, so anyone can download it and take a look at it as well. But if we take a look at running the server, I don't know if I have a highlighter, but where we see like command spark hum sbin spark connect server .sh, all we're doing is essentially adding some packages, and one of the important ones is the Delta Connect server package. So that's an extension to our session that allows us to be able to run the Connect server, which is essentially like an extension of Spark Connect itself. Aside from that, we also need like command and relation plugins to be able to understand how to essentially transform a command that Spark Connect understands to something that the Delta plugin understands. And it's much easier just to see it all working. So moving on to the client. The client's essentially the same thing that we saw for the server. It's like, yeah, this is super exciting, right? So I've highlighted here the actual like Delta like Connect client. So as we start our local, what I was talking about as like our local kind of fake Spark session, we're just basically spinning up a normal Spark session with a thin client. So our Spark session actually is really just a conduit for sending messages back and forth to the actual server side Delta service. And so with that said, there's really two things. I said there's like one tiny modification. There's really two. So everything has to run. So it has to be running. The server has to be running. So that's already two things. But the tiny modification is that we have to identify what the Spark remote endpoint is. So if you've ever connected to like, Spark : // this is really no different. It's just SC for Spark Connect : / with like the host name and the port number that you're going to connect to. The default is 15002. So that's been left off in everything within the demo, other than when we actually like just, talk about things in the README. So all you have to do is add an environment variable. If you're like the environment variable, I don't want that because I want people to know what's going on. Then on the Spark builder, like over on the right, you'll see like builder.remote, and you just pass the remote endpoint, and then your session ends up being like a gRPC session rather than one that's just speaking like the typical Spark protocol. And then I highlight that as well. Like if I do type Spark session, we'll see that it's SQL Connect session, Spark session. And so there's just a little bit of a difference, but everything else feels the same. We're now running with gRPC instead. All right. So how does this all kind of come together? We're going to look at this in the actual session in just a sec, like when we run the live demo. But if I take a look at like a normal kind of data frame type operation, so say I have a source Parquet table and I want to convert that to a Delta table, and then I want to save that on a path. Like it's a typical simple operation. So called it out, the proof's in the pudding, right? It's like, we're going to go test this. We're going to make sure that it works. Because like Delta Connect is still in its early days and it's considered experimental. But while it's experimental, it doesn't mean it doesn't work. It works really well. But the interesting thing is if you've taken a look at like any kind of like logical plans or like kind of like a dump of operations before on like the Spark side, if you've been debugging, it's neat to be able to take a look at kind of the subtle differences in like the planning. So on the right, we'll see like Spark Connect. We'll see we have a session identifier because I might have a session, Youssef might have the session, we might have different users with different privileges. And so each session has its own capabilities and permissions as well. And so I'm doing something on my behalf, you might be doing something on your behalf, and the same kind of concerns of like any sort of shared clusters come into play. Like what's my Spark user have, as in terms of capabilities. So anyways, without further ado, we're going to start to transition now into the actual demo, and we're going to hope that it actually works. But we're going to give you a little bit of time. If you want to take a look at the QR code, that's going to be a reference to the Delta Connect Playground, which will allow you to go and actually test everything that we have here on your own as well. There's some READMEs. I'll walk you through what that actually means, but we're going to get started with that right now.
May God of demos be with you.
Thank you, sir. All right, so starting off, finding the mouse. One of the things that I wanted to just kind of call out real quick. So there's a lot of data, and that data has to be downloaded externally to be able to run everything that's currently in these tests or in this like a demo environment. And we're doing that because we don't want to bloat the download size for people, and then people can opt in to either decide that they want to run with the e-commerce data set, or they can run with anything else that they want to run with as well. At the end of the day, we're just taking these CSV files and we are going to be reading them into, so we're going to read our CSV files, we're going to transform them into Parquet, we're going to write the Parquet first to show you that Spark Connect is working as expected. On the second pass, we're just going to take the Parquet, we're going to write it to Delta to show you that Delta Connect is working. And then we're going to conclude by showing you what actually happens when we read everything else back with a couple transformations. So without further ado, we're going to go and run the Delta Connect server. You can tell that the Delta Connect server is running when you get to the Spark Connect server started at blah, 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 15,002. On the other side, we're going to run the Delta Connect playground. And this is just a Jupyter Lab environment, and that's going to get up and running. And then I need to go and find this over here. So we get to the local lab address versus like the internal Docker lab address. We're going to kick that open. So right now we're starting off with absolutely nothing in our data set other than like our raw CSV. So we're going to walk through everything just end to end. So I'm going to first go through, I'm going to create my new session. And then from there, we're going to take a look at the type session, make sure that everything is exactly the same as we expected. So PySpark SQL Connect, that's awesome. We're going to go bring in our types. This part's really fun, just walking through it. So our data set dir is basically set to our Spark working directory inside of the Docker container, which is opt spark work dir. And then data sets is bringing in e-commerce raw. So all we've done is basically done like a virtual mount of the data set ecom when we ran the Docker compose. We're creating our two data sets over there. And now we're just going to load in the first data set over here. So we can take a look at that as it's actually working. Like it's kind of, as it's working. See if it's working. Cool. Okay. So some stuff is like really fast, and some like it's interesting to see like how things are actually kind of working for all of that stuff as well. So we took our CSV, we just loaded it, we took a look at it, right? Not much is happening there. You can run the count on it as well to see like how many actual records we have. And we're going to see something around the lines of like 43 million, something like that. So it's going back and forth, it's processing, it's asking like the remote server for all this information. So it's having to aggregate all of that and then bring it back down. Remember, this is CSV at this point, so we don't actually have any statistics. So have all of that stuff. We're gonna bring in the November data set as well, do the same thing. Yay, go do the count on that one. And then we're gonna actually go do some actual work. So far, all we've done is just brought in like the two CSV data sets. We've created data frames for them so that we can essentially kind of go and do some work. So right over here, I want to bring in this e-commerce data set, starting off with October. And so you'll see that we get a new Parquet directory as it's starting to actually write. And so all of this stuff is like up and like running in our server environment. I know it's like a Docker environment, so everything feels like it's all in the same place. That's for simplicity. But the processes that are running right now are essentially like the Jupyter environment and then like the server side, which is where all the work is actually happening right now. So this will run. I know it's not the most exciting job to watch in a live demo as our Parquet is continuing to run and run and run and run and run. And so we'll just update this over here. We'll take a look at it and we'll see that we now have everything that we need. If I can just scroll that over. So right now we have an entire month worth of data for that. I'm going to kick this one off anyways, just because why not? And this will just give us all of November as we kind of go down. So this is a Kaggle data set that has e-commerce data from 2019, and it's got 2 months of like view data and a bunch of other cool stuff as well. So if you've ever been interested in like retail data, it's a really fun data set to play with. So as that one's going through, we're just going to go over here and wait for a second, load up our Parquet over here. So what we're going to do now is essentially just go and create like a Delta table. I'm going to wait for this operation to stop. I apologize for this taking a while. It's almost done though. Almost done. Come on, demo gods, make it happen faster. So if I had a bigger, like, so while this is running, let's pop up localhost. So we'll see that like Spark Connect is running. We've got a session. My user's nobody because I'm running locally as a user called nobody, and I have no user identifier for that. But we can see like essentially like every single one of our operations. The statement is essentially like it's the parsed view of what we were sent as like our logical plans. And that's been parsed and turned into an actual operation itself. So this is now done. I'm just going to go through this again. So now we have like 2 months worth of data. That's great. This is the first real test of actually using like Delta Connect. We should be able to create this table and actually have it work. So now that we have a data frame, we know that our table exists over there. We've seen that we have a new folder called Delta that has our ecom data, and we have our staged commits over here. So we know that we're using we're using Delta 4. We've got a table like, essentially set up with nothing in it. And so now all we're going to do is essentially write all of our Parquet data over to that Delta table. So this is essentially just testing that everything is working as expected for, let's go into our stages over here. So you can take a look, right? We're reading our files, we're mapping. These are all whole stage code gens. So we're not seeing like a lot of like the interesting like nuggets that are occurring right now. But if we go over into the data frame, hold on a sec. Just wait for this thing to finish. Okay. Did it break? Oh, let's run that again. We might have just hit it. We might just hit a little snag. Or it might just be like off by 1. Go, go, go. Okay. So right now everything is being compressed as like Z standard for all of our Delta. So we see like a bunch of work right now going on the left-hand side. So we have essentially we're writing everything like in parallel, so we can just take a look to see how this thing is kind of growing out as it grows over time. This might be kind of boring, so it's just running along, which is great. Take a look at all of our jobs over here as well. So for every job itself, anything that we send over, so like every individual action, we can consider that as like each time we've essentially pressed play inside of a cell, we actually have a command that's been sent over. And so the command is also part of those plugins we initially looked at when we were taking a look at how to like set up like the server and like the client. And so I think this is almost done. Cool. Let's see how we're doing. Cool. I'm happy with that. Looks like we got everything now. All right, so the last thing over there, so we just finished a bit essentially writing. This is what we showed like in the demo where it's essentially, we're writing our Delta, we've got our path, we've got our source Parquet. The source Parquet is essentially just a normal command to be able to read and write Parquet that Spark Connect already knew. And the only difference is essentially the Delta format, which came in through that plugin. So now if I want to read from my Delta table like I would any other Delta table, if I want to take a look at dates between like the 6th and the 16th, and I want to take a look at only views and I want to order by ascending, I can now do that, running it all on the server. And then all I'm doing is getting back essentially just a buffer that can be essentially read back into a data frame locally. So that thin client, all it's actually doing is essentially, it's like if I could speak data frame, right? It's probably a better way of talking about that, but that's essentially all it does, is it takes the data frame, it knows how to read and write from a data frame. It's just asking somebody else for all the help. And so with that, that's pretty much the demo. And I'm going to kick it back over to Youssef now.
And here you go. Thank you, Scott. I think gods were with you, almost.
One slight problem. So.
Yeah. And here you go again with liquid clustering. It's one of my favorite topic. Just want to make sure that if we have new joiners, they might want to know about liquid clustering. This is a really modern way of efficiently organizing data. So rather than having to partition them or like order them physically in the storage, you rather organize them logically thanks to liquid clustering. So I'm pretty sure you're familiar with the first SQL query. So you see that you can create your delta table and then you specify partition by, I don't know, can be for this case type or value. Liquid clustering, it's almost similar. You just need to replace partition by cluster by, and that's it. It's very easy. Sorry, and it will be super important. Why? That's what we're gonna see right now. So basically, when you want to modify a partition, you would need to rewrite the entire delta table, which means if, I don't know, you have a table with the size of 1 terabyte, you would need to rewrite the entire table, which can be time consuming and can be a little bit also expensive. While for the clustering, you just need to alter the table, as you can see, alter table, and then cluster by, and you specify the new value. Of course, you can go up to 4 clustering keys or columns. And this is very efficient. Why? Because you can, when you run the optimize, it will run only on incremental data. And this is very important. Why? Because now if you go with partitions, when you run the optimize, it will run on the entire dataset, including the files that were already optimized, unless you specify, for example, a where clause that should be available for partition tables. But again, it will only work if you have, for example, date, because you can specify, for example, optimize a table customer where date is higher than, I don't know, 15th of July, 2022. While for liquid, it just, if you added one row, if you run optimize, you will of course optimize only this additional row. And if for somehow a reason you need to recluster the entire data set, you can just write down the optimize, the table name, and then add the command full. It will recluster the entire data set. But again, I won't recommend you to run it often. Like, run it only if you see that you did recluster your table so many times and it might have impacted the table. Then you can run the full. And I guess you may have a question, if I'm partitioning my tables, how can I move to liquid clustering? Well, if your table is already partitioned, you would need to rewrite the entire table. You cannot just move it to the clustering. And if you're already, like, as you mentioned, using the clustering plus the zorder command, you can reuse the same keys, as that would become now your clustering keys rather than the partitioning keys plus the zordering. So this is very important. You can also, if you already used what we call generated columns, you can also use them. And of course, the same as I mentioned, Hive partitioning, that's what I mentioned, plus zordering. So it's almost the same thing, but you have more additional features. Just keep in mind when you use the clustering, you're going to automatically activate upgrade to the more recent protocol reader and writer, and it will automatically enable deletion vectors, column mapping, and row tracking, if I'm not wrong. So basically, deletion vectors will help you avoid rewriting every time the Parquet files. That's for deletion vectors. For column mapping, it allows you to have space or special characters in the name of the columns. And then row track, it avoids concurrent queries, because for partitioning you avoid the concurrent writing, because you can write to multiple partition at the same time. While for the liquid clustering, since it's not, let's say, partition, but it's logically, row tracking can help you avoid those conflicts. I don't know, Scott, if you have anything else to add.
No, I think the big thing is that, like, for unoptimized tables, moving to liquid clustering is smarter. I was also thinking too, the demo that I was showing was all essentially just using Hive style partitioning. And it'd be interesting to basically go and modify that to show what it looks like with liquid clustering as well. I'm going to do that after the session's over. So it'd be interesting to see how the performance looks after doing like those optimizations as well. I mean, it's local, so it's like, you know. performance will be good.
Yeah. And I think the next one is called Collations, and this one is pretty new. Again, part of Delta 4. And basically, it does introduce collation support, allowing user to specify how string values can be ordered. And of course, when I'm talking this, you will use it to compare the data. And this also will improve sorting and searching within the data. And as you can see in the example, so I have a bunch of names, some of them starting with capital letters, others not. And then I asked like, hey, order this table by first name. And as you can see, I have Aaron twice. The first one is with capital letter, and the second one with not that. And as you can see, it did order them, but not as I was expecting. So with collations, as you can see, after, now that I ask like order by first name, you can see that Aaron are both ordered in the same or let's say clustered, which can help me. For example, in case I have customers, sometimes I add my name with a capital letters, sometimes not. I can order them maybe and reduce redundancy or whatever other things that can be used, and also use for people who may, I don't know if they're using a data warehouse, moving their data to a data lake, to Delta plus open source Spark. They can use it easily. And how I can enable collations? So as you need to know, by default, when you create a Delta table, it's UTF-8 binary. And my recommendation, and this is important, make sure to use it with Spark 4 Plus, because it will have, let's say, more accuracy. And trust me, this feature is amazing. Why? Because you can enable it at the table level. For example, you can define that all the columns within this table will have a default collation, which is UTF-8 underscore lowercase. Or if you, for example, within the same table, you can have maybe multiple options. You can define it at the column level. If the table has already been created, you can just use an alter column, alter table, alter column, specify the name of the column, then just add the collate at the end, and with the coding. For example, in my case here is Unicode under CI under AI. Or if you are creating a brand new table, you can define it at the creation. As you can see, I added here the collations for 3 different columns. The first one is UTF-8 lowercase, the second one is Unicode CI, and the third one is UTF-8 lowercase R3. So you have all the options to make your life easier, basically. Anything else, Scott, on your side?
No, I think I think it's interesting that like this feature itself is something that is available and it has been available in like kind of like traditional like OLTP databases for a long time, but it's nice to be able to see like the performance benefits of being able to do this, especially for, as you were talking about, like for sorting itself, right? So versus just taking a look at like what does like the binary representation look like and sorting based on the bin, it's much cooler to be able to see like this occurring, to see like the Aaron, you know, all within that same little chunk, which is what you'd want to see as well if you're searching, you know, for a lot of matches, like needle in a haystack style. So thank you. It's cool.
Yeah. And I think the next feature is also very interesting, and I think it's very underrated because this type widening will allow you to change columns to a wider data type. For example, going from int to long or double, without rewriting the underlying files. As long as you have, of course, it will allow you to have this schema evolution and make it seamless and efficient. And again, it's super important because the goal is not to rewrite the data. Sometimes the types may change, and you don't want to rewrite those 2 terabytes data. And that's why we talked first about liquid clustering, giving you the possibility to change clustering keys easily. Now we're also giving you the possibility to change the column type without rewriting, again, this data. And basically, this type widening will let you do this schema transition to a broader type, and this is important. ensuring that the existing data will remain readable and the new data will follow the expected type. And how will it work? So basically, when you have this type widening, the table records the new type, and this is important, but the past written data will still remain as is. And this is very, very important. But there is also something very important. Delta-like clients read data using the white type will the widening type. I'm always struggling to pronounce widening. Will handle the conversion automatically, and we will see some examples over here. So what I did, I created the same table twice. The first one I did enable type widening, and for the second one I disabled it at the creation. And what I did afterwards was, okay, now that I created this table, what if I want to switch the ID that was integer to a double? So once I did the alter, the first one where I have the type widening enabled, it was a success. While for the second one, it was a failure because I have to either enable type widening or rewrite the entire table. And also something to keep in mind, and I think this is very important. If you created a table with, for example, ID integer, and somehow you inserted into this ID this column, for example, a float, it will automatically trim and keep only the integer part, which means if you inserted 2.5, it will always keep 2. It will remove those to the 0.5 and you won't have a failure. So this is something to keep in mind. Else you can go with altering the column, and that's not the only thing. So type widening exists since Spark Delta 3.2, but as you can see with Delta 4 we added more possibilities. And as you can see, byte can now go, like, switch to short, integer, long, decimal, and double, short to integer, long. So we gave you now more more opportunities, and also for the date you can switch it to timestamp NTZ, which is also Spark 4 compatible. So that's why I mentioned most of the things should work fine with Spark 4. And you're gonna ask me a question. Okay, should I always go and alter the table to change the value or the type of the column? So yes and no. For example, when you do the insert or the merge schema, depending on whether you're using Python or SQL or whatever language you will use, so it will automatically convert this column, but we have some exceptions. So for example, integer cannot go to a decimal or a double. And same thing for merge into. So those are the same condition. For example, merge into, if you're specifying a condition, merge into a column, and we'll merge into a table from a view or another table, you're gonna specify a condition. Once this condition is matched, you're gonna merge into this specific table. So again, it will automatically take in consideration the new column type, but not convert from, for example, integer to decimal or double. So those are the exceptions. If you want to be sure, just go and do alter table and then alter the specific column and switch it to whatever type you want to be moving to. Just keep in mind that it has to follow those specific source. So if it's not here, then of course you're gonna have an issue. And something I've seen people asking about, okay, what if I activated type widening? I want to disable it. So basically, you can disable it with as I did show you at the beginning, delta.enable type widening equal to false, but it won't remove it completely from your table. And that's why if you want to really get rid of this feature, but again, for some reason, maybe your protocol reader or writer does not support this feature and you're blocked, it's either improve your reader and writer, or you can drop this feature by altering the table, the name of the table, drop feature type widening and truncate history. And this is how you can get rid of the enablement of this feature. Else it will just disable it for the new columns, and the existing one will still be white.
with that in mind of being able to like go and drop this feature, if you drop the feature and you had a table that had an int, and then you manually altered the table to allow it to be a decimal type, and then new data was added prior to dropping the feature, what does the state of the table look like at that point in time?
Sorry, can you repeat the question? I did the block.
No, it's okay. So if I have a table and say like the first 10 transactions have ID field as an integer, for like the 11th transaction, I'm doing an alter table. And so I'm going to change like the schema declaratively, and I'm going to go and change it. It's like the manual operation to go and move it to a decimal type. And then I'm going to go and actually drop the feature after writing in, say like transactions 12 through 20. So essentially it's like, it's integer, split point, decimal. So my table now has like essentially both types in it. What does it look like once I've truncated the history? Does it just still continue to show decimal, and behind the scenes, we're essentially just doing the transformations for the first 10 transactions?
So basically, when you truncate the history, it will stop. It will keep with the feature called the checkpoint. It will keep the existing. If I read this data, I will still read it as is, but the new one will be back to the existing one, which is the integer. If I'm not wrong, it was an integer.
Okay, so it's just going to sit there and it's going to truncate back. This is what goes back to your original. Okay,
Exactly.
this is perfect.
Yeah.
So just going to truncate everything else after the decimal. Perfect.
Exactly. And yeah, and also the next feature I think is also very important, especially for those who has to handle semi-structured data. So basically over here, it does enables flexible and efficient storage of this semi-structured data, and it will make it super or much more performant than traditional approach of storing it as a string and then having to trim it or do a lot of transformations. So basically, in the past, you had to create, for example, a JSON example. It would be an ID, and then your JSON will be stored in the data as a string. While now you can just create a type called variant. And why variant? Because basically it means that this file or this data will keep switching because you don't know how it will look like. So I think that's why it was called variant. And why it's important? Because for three reasons. Now it has a native semi-structured support, so variant stores data in a binary encoded, strongly typed format, enabling efficient storage, indexing, and query performance. And in contrast, string columns require, as I mentioned, parsing to JSON text at query time, which make things slower and very in its resource intensive. And the second option is because of this schema evolution and type safety. So with variant, you can directly access nested fields using the dot annotation. That's what I will show you. Also, Delta Lakes understand the structure and the types within.
Hey, Youssef, real quick. I think the microphone is running out of battery potentially. It sounds kind of like a windy day. Just wanted to bring that up real quick. I'm like sounding a lot better right now.
Okay.
Okay, cool. Whatever
Yeah.
the hell.
So then, yeah. So I said this reduce the errors and making queries more robust. While for the string approach, it lacks type safety and is prone to error prone. So that's why variant is also important. And the last one is about performance. So when you query variants, when you query variant columns, this one are faster and more expressive, and they support advanced analytics. You can use them, for example, with BI tools. While for the second option, it requires like repeating, parsing, and makes like some expressions a little bit complex. So that's why before we need to get JSON and specify the object. While for the second one, I'm just, as I mentioned, because variant was a data type. So now I just access the name and I name it name and then age, and then if it's nested, address dot city and so on. And you can see like you can see a huge improvement in the performance. Just keep, and how can I enable it for existing column? Very easy, just alter table, and you need to set this command delta.feature variant type preview supported. Just keep in mind, and this is a warning, once you enable this feature, this table won't be readable if your client does not support variant data type. As of all the other features I mentioned, it's dependent to the reader, the Delta protocol reader and writer. So the compatibility is required, and variant columns cannot hold data larger than 16 megabytes for now, or as of now. Maybe things will change in the future. And I'm not saying the entire column, but just like for one row, it can be higher than 16 megabytes, but your table can be 2 terabytes. There is no problem. Anything else to add, Scott, over here?
Yeah, I was just going to say that, like, for a lot of people who are testing ingestion of like new data types, and they're not essentially sure of what things should look like yet. Like, a lot of times, like when you're going and you're prototyping a lot of things change often. And variant type is a very good way of being able to ensure that that data can mutate in a way that's still performant. And that's like one of the things I found interesting about like variant type in general. Like, a lot of like the use cases are like, IoT related. And it's like, you have one sensor, but now you want to have essentially like an aggregate of multiple sensors to, have a more performant like read throughput for like an individual table. And to do that in the past, you'd have to join a bunch of different data across a bunch of different join operations to create a new table, or you'd create like a materialized like synthetic table of all the other tables. Or with variant, you can basically just stuff new data into the variant type itself, which is an interesting way of being able to like, modify and mutate data in a way where it's still performant, which is really interesting to me.
And I think I've seen a question like, does the variant type requires any upgrades at the reader level? Yes. So the variant feature in Delta Lake requires upgrading the reader protocol, which means all the readers, not just writer, they must support this feature to read tables that has variant type enabled. And I think the last feature I wanted to mention, it's called checkpoint protection. So Delta 4 introduced this protection, which is a feature that ensures that your table remains safe, and it's still compatible even when you drop some features. By dropping features, you remember I mentioned you can drop maybe deletion vectors. You may drop type widening. So the goal here is whenever you drop a feature, Delta Lake will automatically rewrite the recent table history and protect the checkpoint. And which means even if I query this table, it will still be, let's say, will still function. Because in the past, if you drop some features, it may cause some issues. So this one will prevent the protocol downgrades from being, let's say, accidentally removed during those cleanup operation, which means, and at the same time, it ensures that the older clients can still reliably read this history to be able to populate back this table. And the goal, it says, and as Scott mentioned during the question he asked at the beginning of the type widening, when I said you can drop it. So it does protect the checkpoint mark at the transition point, which means older client can read up to the checkpoint, and your client will handle the rest. So that's how we can make sure that it's still compatible. And this one is part of Delta Lake 4.0. You can find more details in the Delta Lake documentation, but you can also access the code in GitHub. You can see the exact implementation and how does it work. So I tried to simplify it, but it goes beyond what I've just explained easily right now.
I think it's also the interesting thing with it too is that, like, if you think about creating a point of no return where you're like, we're going to force upgrade a table at a certain point because I want to opt into all these new features, by being able to allow an older client to read up to a certain point, it's like a safe cutoff without essentially cutting, like you're not just immediately blocking them, right? It's like, well, you can read up to this point in time before upgrading, which is kind of a nicety to do that, right? Where it's like, you don't have to upgrade today, but the second you hit this data, you'll have to upgrade. And that's cool because it's a way of communicating through the table to a customer about, you know, capabilities. Like everybody, you know, we're always upgrading things, right? From computers to cell phones and everything else in our lives. And like the same thing goes with the data, right? Technology improves for the right reason. And the hardest thing to do is to get people to actually upgrade. So it's like, well, here you go, right? It's like a line in the sand. So this is great to know as well. And there's probably a whole entire like subset of problems that like the checkpoint protection is solving for now as well, outside of even just changing features in the table as well. So this is neat.
Yeah. And I think,
oh yeah, I'm gonna, sorry, I'm like, this is just a picture of me. So Long Vu, who's in the picture with me from like the Open Lakehouse Mini Summit from back in June. I have mine too. I'm like, yay, marketing. Yeah, thank you, Carly, for the wonderful glasses, and I think this one too, my Delta Lake cup. But Long Vu was originally the one who told me about like the new updates to Delta Connect and got me interested in like looking further into it. And so we've been kind of chatting back and forth about like who in the community kind of helped put everything else together. And so it's probably hard to see right now, but essentially everybody who contributed to Delta 4 is in like the call out. And then also like a thanks to like Martin Grund, who came up with Spark Connect originally. And then also like I'm shouting out to Buff, who helped create the toolchain that makes Protobuf really work well within Spark Connect and like the Delta Connect environment as well. And outside of that, I think we're going to move on to questions. So
yeah, and just to answer, I think someone asked a question: what would happen with checkpoint
Oh.
protection when we change column mapping? Yeah, so you cannot drop all the features. You have the list of the features that you can drop using the trunk history, but it cannot be done for all the features. And I got your point, because if you drop your column mapping, then the name of the table, the name of the column will be a problem, because you cannot have these special characters. That's why you cannot drop all the features using the truncate feature.
Yeah, I think so. With that, also for that question, there's an extension of the question. It's like, would we be able to revert to previous state like nothing happened? Because right now, as far as I understand, we're always getting some extra files under the hood that are not deleted if we revert. There's probably like the additional like underscore metadata files and things like that, which I don't have a good answer for that. I haven't tested dropping all features yet, but there's probably things that might kick around. And if you know that they're not needed, you can always go and delete them, but there is always a risk of corrupting the table. So if the overhead's not too high for it, you could just keep them around, even though it's kind of like, you know, it's keeping kind of trash around until you need it again. But I'll go over to the actual Q&A as well. So then we can start to answer other questions as well, if there are any other questions. Or I can just chat with Youssef about, you know, cool stuff like how's Paris?
Well, it's windy. Not that good. Like, haven't seen the sun for a very long time.
Oh, it's sunny right now in California, and you know, if you want to come over here, jump on a plane, I'll host you. So
yeah, next June for DICE.
Perfect. That sounds awesome. Well, if there's no other questions, and people don't just want to hear us ramble, we can call it quits for the day. So thanks for coming. Thanks for coming and for sitting through yet another like a high performance Delta webinar. If there's anything that you'd like to see coming up or other deep dives, we have a whole entire like fall full of interesting deep dives, including a very deep dive into Delta Connect. And if you want to go into variant types, or if we want to go into like Type-Widening or anything else like that, we can commit an entire webinar to really anything. So just reach out to us either in the Slack channels, reach out to us through LinkedIn, etc. Anywhere where you see us online. And with that, thanks. Bye, everyone.